Now here's the situation for the Red Tomato Company. Red Tomato is a manufacturing company that produces gardening tools for consumers. Demand from consumers is highly seasonal, of course, peaking in the spring when everybody is trying to plant their gardens. Red Tomato has decided to use aggregate planning to find the best decisions given its options. Should it add workers during the peak season? Or should it simply work overtime? Should it do a blend of either of those? Should it subcontract production to some of its suppliers? Should it build up inventory in the slow months? And should it backlog orders during peak months of demand? So all of these things can be considered using the model we're going to explain. The decision variables for the Red Tomato model include these, and they're slightly different from that was presented in Namias. So I provide this key here. Workforce, WT, is the same, workforce for each month. The number of people hired, H of T. Chopra uses the term laid off. So firing is L sub T, laid off. The number of, the amount of production, P sub T. The inventory at the end of the month. The number of units stocked out, so there's going to slight definition change here, is that the backlog or stockout situation is described as S of T. Okay, as you recall in Namias, we called that subcontracting. So now we have to have a different term for subcontracting. We'll call that C sub T, the number of units contracted out, if you will, subcontracted for the month. We also have overtime hours worked in the month as O sub T. And of course, N is the number of periods in the planning horizon. Much like we explained for Namias, the objective function is formulated as a minimization of costs. If demand is to be satisfied for the plan, the total revenue is known as the demand is simply multiplied by the price. So the model is simplified to a minimization of cost. Now the objective function has several parts, which are best formulated separately as follows. So I'm going to do all of the objective function in little pieces, and then we'll pull it all together in the end. The regular time labor cost is the labor cost as a function of hourly pay, the number of hours worked per worker per period, and the total number of workers. So in this example, hourly pay is $4, and the hours worked are 160 hours per period. That's 40 hours per week, assuming 4 weeks in a month, so 160 hours per period. These are the input coefficients, and a number of workers is the decision variable. So what we have here is 160. Well, let me continue on. In this example, labor cost is a function of capacity, which is defined by the number of workers instead of the number of units produced. So we're doing it very much like we did in the dense pack example with the Namias. Our number of workers is going to be our capacity constraint, and we'll simply use the number of workers multiplied by the coefficients to determine the cost of producing regular time labor cost. So we have $4 per hour multiplied by 160 hours per period. That's 640 times each worker hired. Okay, so each worker available times 640 will become our regular time labor cost. Our overtime labor cost is a function of the hourly overtime pay and the overtime hours worked per worker per period. Overtime hourly pay is $6, and that's an input coefficient, and the number of overtime hours worked in the period is a decision variable that we will calculate with the model. Note that the limits of overtime and the amount of overtime will be a constraint formula. So in Red Tomato, they've got a limit on the amount of overtime per week, and we'll total that up per month. And we'll calculate the amount of overtime as a constraint formula. So for calculating the overtime labor cost, we have $6 per hour multiplied by the amount of overtime hours. Our capacity change cost is a function of adding capacity multiplied by the units of capacity needed and the cost of removing capacity multiplied by the units of capacity removed. So in this example, capacity is defined as the available labor instead of equipment or some combination of the two. So hiring cost is defined as $300 per worker. That's an input coefficient. And the number of workers hired is the decision variable. The layoff cost is $500 per worker is the input coefficient, and the number of workers laid off is the decision variable. So those pieces of the objective function are 300 times the hired, number of workers hired, and 500 times the number of workers laid off. Our inventory and stockout costs are a function of the cost of holding the inventory multiplied by the units in inventory for every period, and the cost of stockout multiplied by the units in backlog or stockout for every period. In this example, inventory holding cost is $2 per unit per period. That's an input coefficient. And the number of units in inventory is going to be the decision variable. So we'll determine by our inventory balance calculation number of units of inventory, and that will be I sub t, and we'll multiply it by a $2 per unit inventory holding cost. Our stockout cost is $5 per unit per period. As you can see, the stockout cost is relatively high compared to the unit cost of holding inventory. So essentially that represents the relative difference in backlogging a product to the customers. That's kind of a definition of the cost of customer dissatisfaction is relatively high compared to the cost of holding inventory. So typically this is how those kinds of decisions are made. You make the relative cost of holding the inventory low compared to the relative cost of backlogging or stockout, as that is customer dissatisfaction or lost margin in revenue or a similar kind of economic value to dissatisfying a customer. Next, let's look at the material cost. Material cost is explicitly included in this calculation of total cost. These are the material cost per unit multiplied by the units produced. So this is that variable cost portion of the production of the product that does not include overhead and does not include labor cost. We're accounting for those separately. This is only the material cost. In this example, the aggregate unit of material cost is $10 per unit for the gardening tool. That is an input coefficient, and the number of units produced in the period is the decision variable. So here is our production that will be determined for every period, and here is the unit variable cost of material, $10 per unit produced. Our subcontracting costs are a function of the purchasing cost per unit multiplied by the units subcontracted. So in this example, our subcontract purchase cost is $30 per unit. That's an input coefficient. And the number of units contracted in the period is the decision variable. So C sub t is the number of units contracted out, and the cost per unit is $30 to buy it. So make versus buy decision, we determined that the buy cost is $30. Now here is our complete objective function, again defined as a minimization. This is the summation of all of those costs that we just previously developed. You know what, I should begin, let's see, how do I do these? Oh, okay, well, I'll start switching back and forth between the model and this definition. Here is the red tomato model. First I want to describe the inputs so you know where those are. Those are on a separate worksheet. And you can see that the first input is the demand forecast, January through June. In this model, you can actually adjust the price if you wish to. And for those students that want to look